So there are some technical solutions to the space debris problem, and while many of them have been demonstrated in space, none of them are actively in use. We only tend to avoid collisions and reduce their impact on our space assets as opposed to tackle the problem of space debris directly. But why is that? And what other challenges exist when it comes to this topic? What would be the business incentive for removing space debris, or who would pay for it? Obviously, building sweeping satellites and cleaning up space debris costs money. One concept proposed to resolve this issue has been a space debris tax. Basically, each entity launching a satellite will have to pay a fee or a tax. These fees can then contribute to a fund, which is managed either nationally or internationally and used to fund the space debris removal operations. In this method, by raising the private cost of further polluting the orbits around Earth, and possibly including different fees for, or tax brackets based on the pollution potential of different activities that private entities take part in, private entities will likely act in a way to reduce the cost on themselves and improve the space debris situation in the process. Another solution is a clear rule placing the financial burden of damage due to space debris on private actors, which would incentivize these actors to take action against the debris they create. Some have proposed another business case, that of orbital recycling. Considering a major cost of sending objects to space is launch costs, a company could potentially gather the scrap that is already in space and make new objects out of them or salvage the components. For new satellites, new national regulations could be introduced, forcing companies to include the cleanup costs and procedures as part of their budgeting process for the mission, so as to prevent an increase in the objects up there. Companies such as Astroscale are banking on this idea, planning to provide deorbiting services for a few using a reusable chaser satellite and limited changes to the design of the satellites that are being built. What is space debris? In the first video, we explored that, but that is a technical definition. From a legal perspective, believe it or not, we have this thing called space law. There is no adopted definition of space debris, so already we have a problem. Yet several national and international legal frameworks have been proposed to tackle this problem. At an international level, these include the Interagency Space Debris Coordination Committee or IADC Space Debris Mitigation Guidelines, the European Code of Conduct on Space Debris Mitigation, and the ISO Space Debris Mitigation Requirements. One of the major outcomes of these guidelines has been the 25-year rule, which states that objects need to deorbit 25 years after their mission lifetime. The United Nations Long-Term Sustainability Guidelines for Space Activities have been the latest effort to streamline these guidelines that already exist. They aim to provide a more strict set of guidelines with timelines as short as 5 years after Operation cease for deorbiting an object being discussed. However, perspectives of newly spacefaring nations who might not have the capability to deorbit their satellites has affected these debates. While the international frameworks are guidelines, countries such as France have also developed and enforced national laws addressing space debris, which is more enforceable. While space debris is debris, it still has a legal owner or liable party. According to the Convention on the International Liability for Damage Caused by Space Objects, or what we call the Liability Convention for short, the launching state is liable for the spacecraft and any damage it might cause after it ceases to operate. The launching state itself is a complex concept to define and can range from the country where the satellite operators or manufacturers are located, the country that actually launches the object. Now, if the process of removing space debris or servicing satellites, you damage more satellites, your country is responsible. And this is kind of the issue. Since this is an international law, the liability is on the country, and the country has to have relevant national regulations to transfer this to private parties. In many cases, these national regulations might not exist, which creates a problem. There's also a security issue to think about when it comes to space debris. What if the satellite is hacked through the servicing satellite? What if a chaser satellite is used to destroy another country's satellite? What if a military satellite was removed from orbit and landed in an enemy country? What would happen to the technology that is on these satellites? All of these things make space debris removal and on-orbit servicing rather sensitive topics of discussion. Another challenge of space debris mitigation and avoidance is the fact that we cannot track all the objects up there. The US Space Surveillance Network, or SSN, is under the control of the US Space Command and is currently the actor with the greatest capacity to track objects through a network of ground-based sensors around the world. In addition to the US system, the European Space Agency and the European Union also have a Space Situational Awareness System, or SSA, under development, while in Russia, the Russian military operates the Space Surveillance System, or SSS. The US provides the data through its SSN to users using the Space Track portal and also informs satellite operators of imminent collisions. Despite their capabilities, all of these systems that I talked about are in great need of upgrades in order to cope with the rapidly growing space activities worldwide, and also to improve their accuracy and be able to track smaller objects. In addition to tracking objects in space, according to the Registration Convention, each object being launched needs to be reported to the UN, which keeps a register of space objects. Industry associations, including the Space Data Association, also encourage a voluntary database of space objects in order to reduce collisions. Many smaller satellites are also fitted with a tracking tag, which helps some of these networks like the SSN identify and track them after launch. From a technical perspective, while there have been many advances in demonstrating the technologies that we talked about, for example, in our past video, there is still much to develop. We are still testing the best technology to grab non-cooperative objects, or basically that means uncontrolled objects, and bring them under control with an operational spacecraft. We want to move towards on-orbit servicing. Some standardization in the design of satellites and modularity in terms of the different components of satellites is needed, which is something new and requires collaboration between different companies and organizations. Orbital debris removal can also benefit from such standard interfaces in the future. Interfaces of space debris with satellite signals, interferences of space debris with satellite signals, or the increasingly limited space in the geo region of new states to put their satellites in, are currently the most debated topics by the space community. So, through these 3 videos, we talked about space debris, and I hope you kind of took away from this that space debris is a bit of a problem, not one that we will be able to resolve anytime soon. However, there needs to be a push towards not just avoiding the topic and avoiding discussing it, but actually acting on it to resolve this issue. On-orbit servicing and space debris removal are key to this future solution, and for them to work, there needs to be an international support from policymakers around the world. Let's hope for a day that this happens. Thank you for watching this episode of Let's Talk About. It basically ends our discussions on space debris, but don't worry, something interesting is coming next week, so stay tuned. Thank you for watching.